Hello, everyone. Welcome to our Vue.jsTalks number 18. If you are here live, that's awesome. If you are watching the record, hello from the past. We hope future you is doing really great. Today is the perfect mix of learning plus therapy for front-end developers. We'll talk about performance, builds, migration stories. So basically, all the things that keep us awake at night. Let's do a quick intro, and then we'll jump into the good stuff. Okay, quickly about us. We are Epic Max. We build web apps mostly with Vue and Next, and we care about the details, performance, clean architecture, and making things not explode in production. We also genuinely love to code, like the kind of love where you say, I'll do a small refactor, and suddenly at 2 a.m. and you wrote the half of the project. So if you ever optimized 3 kilobytes from a bundle and felt proud, you are among friends. We also build a VueStick UI and VueStick admin. VueStick UI is our Vue 3 component library. Buttons, tables, forms, all the classic stuff, but done in a way that doesn't make you cry later. And VueStick admin is ready to go admin template, basically Control-C, Control-V, ship dashboard. So why did we run Vue.jsTalks every month? Because the Vue ecosystem moves fast, and it's more fun to learn together than alone. This meetup is a place for practical stories from real projects, things that actually worked, and lessons we learned the hard way, so you don't need to have to. Today's agenda is a chef kiss. First topic would be performance optimization techniques from Bytes to builds on Vue.js. And the second one is a GitLab journey from Vue 2 to Vue 3, a real migration story, not just hello world, but the big product with real constraints. We'll do a quick question and answer after each talk. So save your question or post them into the chat. And let's move on to our first speaker, which is Revant Kumar Pata. He's a senior front-end developer, not the first time on our meetups. He is founder of Vueverse and deeply passionate about learning new technologies, writing technical blogs, and organizing tech meetups. Hello, Revant. How are you doing?
Hey, hi, Pavel. I'm doing great. Thank you. What about you?
Amazing to see you there. So I'm passing the mic to you.
Sure. So let me share my screen. I hope you guys are able to see my screen.
Yes.
Okay, cool. So yeah, good evening, everyone. I'm Revant Kumar, working as a senior front-end developer and founder of Vueverse. So Vueverse is a Vue.js community, and it's completely focuses on Vue and its ecosystem. So yeah, let's get started now. So performance optimization in Vue from bytes to builds. Okay. So like for example, today we are going to cover all these agenda, like understanding why performance optimization is very important in our modern web apps and how we can optimize bundle and build. And also we are going to like know how we can optimize the rendering, reactive performance optimization, component and state optimization, asset and image optimization, and network and API. And after doing all these optimizations, how you can measure them. So like whenever you do something, you need to measure, right? So how much you have optimized your web application, you need to measure it. So what are all the real world best practices that we need to follow as a developer also, and as a developer how you are following all the best practices, and also what are all the features and things that our Vue.js is providing for us. So these are all the things that we are going to discuss today. So for me, like let's start with the first question. Why is front-end performance is important for us? What does front-end performance will lead to, and how it will increase? So like I have four questions, like how fast an app loads. Have you ever thought about these four questions, like how fast an app loads, how responsive our UI interactions are, and how efficiently our resources are used, and how well the code is organized. So as a developer, we need to always keep these four things in our mind, like how fast an app is getting loaded. I mean, like when you open like your localhost 3000 port or 5073 port, or in your dashboard or home page, your app needs to load immediately within fraction of seconds. It should not take much time to load. Okay, so that is one thing. And also the responsive UI interactions are like, for example, if I click on a button model and it is taking much time to open a model or pop up something, so again they are not in a good way. And later, how efficiently we are using our resources. So like for example, if we want some four different components, date picker and like select button and all, we need not to install all four different packages, four different npm packages. So we need to choose anything in a very proper way and wisely. So that is the third thing. And as a developer, this is very important step, how well you have organized your code. That is also like very important in writing any of the code. So why performance matters? So we always talk about we need to improve performance of our web application, but why does it actually impact? What does it impact actually? So here, performance optimization leads to better user experience. Okay, as I'm discussing in the previous slide also. So as your user is interacting with our web application, he need to feel so interactive and engaging. So instead of it's a bit laggy and very loading and like opening it in a very laggy way, so we need to make our user interactions in a very easiest and engaging way, interactive way. So that is one thing. And improved SEO rankings, that is second thing. And higher conversion rates. So if the web application or website that you have made is very engaging and interactive, automatically the people will tend to use your website other than any other website in market. That is a third thing. And lower infrastructure costs, not only infrastructure costs. So always remember, better performance optimization, better performance leads to indirectly the cost savings. So that is the most important thing. Like how it will leads to cost savings is like, for example, if you are using any APIs, and API optimization will lead to like it will lead to the lowest bundle. Like for example, if a API is taking much time, okay, so faster APIs will lead to less computing consumption, and effective rendering will lead to reduced server load. So smaller bundles will lead to less bandwidth usage. So this is how actually our cost will also be saved. And not only that, this is again the important point here, so that is better developer experience. So as a developer, while you are coding, you need to feel better, you need to feel interested, like before you code something. Like for example, if you run npm run build and it is taking around 5 to 10 minutes just to build your application, a small application, so how a developer feels, okay, how frustrated the developer feels, right? So like based on all these things, like yes, performance matters, right? So now let's discuss about bundle optimizing strategies. So before we go to bundle optimization strategies and any other different strategies, our Vue.js also provided many new features. Like for example, async components, lazy loading. Like there are also some built-in components like keep alive, suspense fallback, and also there are some directives like vmemo and vshow, how to use them in a very wise manner. Not only that, when to use computed, when to use watch in a proper way. And so in this way, there are many other different ways. Using Vue.js only, we can optimize our code in a very good way. Okay, so but first let's explore how we can optimize our bundle. Okay, so what is bundle? Bundle is nothing but when you write npm run build, when you run npm run build, our code will get bundled. Okay, a code will get bundled, and that bundled code has only three things: what are all the images or assets that we have used, and later html, css, and javascript. That is the only thing will be there in a bundle. Like for example, we'll be using many .ts files, .vue files, and .js files, and many other .jsx files, .jsons. But these all files will not be able to pass to our browser, right? So the only browser can take only these three things, like .html, .json, .js. So whenever you run npm run build, our roll up or roll down, which is recently introduced, will come into picture. Production build will happen, and a bundle will be generated. So that is this thing. So how to optimize that bundle is our the topic. So how to optimize the bundle is, we have four things: code splitting, lazy loading components, tree shaking, and removing unused dependencies. So code splitting in the sense, instead of writing the whole code in the same file, and you're not even bothered about how many lines a component is going to reach. Like for example, if your component is going to reach around 200 plus or 300 lines, so that means that is the end point. Okay, if the component is going to reach more beyond that, like 300 400 plus lines, so that means it's a time to split your code into two or three components. Okay, so this is how you can split your code into different components in a reusable components, maybe, or reusable logic. So that is first thing. And lazy loading components, lazy loading components in the sense, you need to load the components whenever whenever that component is needed for you. So that is lazy loading component. That means on demand loading, we can say. And later, tree shaking. Tree shaking in the sense, sometimes what we will do unknowingly, or sometimes we may think that this may be used in future. So we will be, what we will do is, like, we will import everything. Like for example, if you are using any package, so you will import all different functions that which are present in that package. So in that the whole thing, you may use only two or three, right? You will not use everything. So the tree shaking in the sense, you are removing unused imports. And later we have removing unused dependencies. Like for example, to solve only one single problem, we may install two or three different npm packages. So we should never do that. Like for example, to get an id, we at present in our Vue.js we have uuid concept. Okay, that is uuid we have, or else ref id we have. So now, like, instead of installing some other different third-party packages or libraries, like, we can now completely do from our Vue.js only. So these kind of things we need to choose very wisely before doing or installing some other new packages or libraries. So that is the first thing. And later, code splitting example, as I said, we need to split the code. How you can split our code? Like for example, we have used dynamic imports. We have, like, dynamic imports in the sense, I'll be showing you with an example. And not only that, load components only when required. As I said, you need to load components only when they are required. Like for example, when you are opening any website immediately, so it will go to your home page. When you went into home page, there is a button. When you click on that button, then only that model or pop-up will open, right? So that will comes out. So if you load that model component or pop-up component immediately when you load the home page, there is no use of loading that model or pop-up immediately, right? So you need to load that component when you click on that button. So that is what we call it as loading components whenever you require. I mean, like, lazy loading components or on-demand loading. And not only that, we have our built-in components, as I said, that is use, keep alive, and suspense fallback wisely. So these are also built-in components which are there in our Vue.js. And not only that, we also have lazy loading routes. So lazy loading routes in the sense, we will be dealing with SP applications, like single page applications. So in our single page applications, we'll be having home, about, contact, settings, profile. So these kind of pages we may be having in our nav bar, right? So instead of loading all those components at once, okay, when you are in home page, you only see home. You will not see about page, right? So when you go and click on about.view, I mean, like, when you click on that about in navbar, then only that about.view can be loaded. Am I right? So by this, what will happen? So your bundle size will be reduced a lot. So this is what we'll be calling it as lazy loading in routes. Okay, and not only that, it will improve first, and it will also make our loading performance very fast. Okay, and this is also a very interesting concept. We Everyone knows what is vif, what is vshow, and what is vmemo, but we may confuse sometimes when to use what. Like for example, we will be normally understanding what they do, how they do, each and everything. But sometimes when you are leading with when you are dealing with like when you are dealing with any big component, in that component assume like we have asynchronous calls we have, and there are some other things we are doing in a component. Okay, so and that component needs to load based on some condition. So conditional based we are loading that component. So at the time, instead of using we if and we else, we can go with we show. So why we need to go with we show is, when you are going with we if or we else, the components completely removed from our DOM, and again it needs to be re-rendered freshly. So that means we are giving some extra efforts to load that whole component into our DOM every time. So instead of that, we can completely load our component into our DOM completely by defaultly for the first time, and later we can just use vshow. So based on the condition, we can just hide or we can show that component, but the whole component will be still in our DOM. It will not be completely removed, right? So this is one of the example. This is not the only use case I'm talking about, but this is one of the example. And not only that, we also have vmemo. So what is vmemo? uh, so memo in the sense vmemo in the sense, it memoizes the value. Like for example, there is some constant fields or constant data is there using h1p or some of the data which is not even changing dynamically. So you need not to load that thing every time, right? So like for example, if you are going to that page at least 2 or 3 times, then you need not to load that data every time when you visit that page. So instead of that, you can just use vmemo. So when you use vmemo tag, that content will be remain as it is, and it will be stayed in memoized state, and remaining the whole content which is dynamically needs to render, that part will only gets rendered. So that is one thing. And not only that, we also have two more things: computed and watch. So computed and watch is also functions, but when to use what, again sometimes, not sometimes, I can say most of the times, developer tend to confuse. Like for example, this may leads to side effects also. Like for example, when you need to use computed, and you have used watch, and when you need to use watch, you have used computed. So this may leads to some frequent re-renders, and also you can also lead to some side effects also. Like I'll be showing you with an example when to use watch and when to use computed in a practical way. So this is now. And later we also need to use key attributes when you are dealing with buffer. Okay, because it may lead to some unwanted re-rendering. So this is always, as a developer, we need to use them in a good way, so that we can avoid the re-rendering issues. Okay, so now for example, yeah, this is the thing: vshow and vmemo. So conditional rendering, for DOM rendering, we'll be using vif, and vif we can be used only for few things and few normal things. And when you are dealing with the big components and big asynchronous components, then it's better to choose with vshow. And then vmemo, it skips unnecessary re-renders and it memoizes the value. Okay, and later, yes. So computed versus watch. So what is computed and what is watch? First, let's see that. We all know that, but what is computed? So whenever the value changes inside of that computed, whatever the value that we have used inside that computed, whenever that value gets changed, automatically our computed will get triggered. Okay, so computed is a function, but it can be treated as a const variable. Okay, and watch is nothing but, it is a thing which will be triggered when some of the value will change, that we are watching it. Like for example, there is a router. So when you go from home page to about page, so we have changed the route path, right? So from home page to about page, when you are watching that router, so immediately at that time this watch will get triggered. So these both acts in the same way, but they are not in the same way, right? So we'll be able to see some good examples. So yeah, computed versus watch it is. So let's see here in watch, these are all different four types of watch that we have in this slide. So now, which watch is the correct one? Can anyone guess? And where we need to change it to computed instead of watch? Any guesses, if possible? Okay. Let me say. So, like for example, here we are checking to-dos dot values dot length. So whatever the to-dos that we have, we are checking its length. So whenever that length gets changed, we are using console.log of length. So here we can use this watch. We can use this watch as we are just checking the length of the to-dos. Okay, and here what we are doing is watch, we are watching what, we are watching each and every value, each and every to do is done or not. So here what we can do, here we can do here computed. Why we can do computed here? So here we are trying to do some calculation. Here we are trying to change the here we are just trying to change the reactive property of these to dos. So like when you are trying to do some calculations, when you are trying to do some change to the like variables that we are using in our like component, so at that time we need to use computed. And when you are just dealing with some variable and you are just seeing whether that variable watched or changed or not, if the value is changed, then only you are going to do some API call or do some operation or something. At that time we need to use watch. Okay, so all the side effects and everything will be used in watch normally, and all the calculations and reactive property changes will be used in computed. And later here, if you can see, here we are completely observing the whole to dos. And what we are doing here, we are also doing deep true, and we are also checking each and every thing, like the to dos dot value dot filter dot length is done. I mean, like what are all the to dos that we have marked as done, we are fetching that length. So here what we are doing, we are just trying to do some calculation. So here we need to use computed instead of watch. So this is a kind of this may be a basic one which I've taken example of to dos, but in our day-to-day life sometimes we may get confused when to use what. So we need to choose when to use computed and watch in a wise manner. Now let's see reactivity performance using like deep, when we need to use deep watchers, and instead of using deep watchers when we can use shallow refs. This is the thing. So like for example, shallow ref, I mean like shallow copy, deep copy, and all these things. So instead of using deep watchers, sometimes we can go with watch effect. Okay, and what will be like deep true will do is, like for example, if you are dealing with a nested object, instead of checking the whole in nested key value pair, we need to use at the time, instead of watch we can go with like this. Like for example, to dos, instead of watching these to dos, we can specify the property. Like for example, to dos dot value dot and something like name. So instead of watching the whole to dos, what we are doing here, we are watching only that one property. Okay, so at the time we can remove this deep true, and we are only watching that property of the to dos. So to make it easy, instead of watching the whole complete list of to dos, what I'm doing here, I'm specifying to the watch what to watch inside that to do. Okay, so making it in a easy way instead of using deep true. So in that way, and also asset optimization, like there may be some cases using a PNG and also some high resolution images. So at that time we need to use WebP and AVIF, AVIF images. And not only that, using icons, like there are some many big libraries that most of the projects that will be using, like for example, font awesome icons, or like for example, there are some other component icon libraries that we have. But I have listed two of these icon libraries, which are hero icons and feather icons, so which are very light in weight, and also uh, which can be lead to in a like very shortest bundle size. So that is one thing. And yeah, so this is another thing. And later, like always, we will be dealing with these kind of things whenever we are dealing with any enterprise level applications. Like for example, if we have a large data set, like for example some thousands and 10,000s of records, okay, so when you have some 10,000s and like the whole large data set, what we are doing, how we are handling. So we can do three things from front end. Yes, we can do many things. Usually there are many approaches, but from front end we can do these three things. So that is one, pagination, one which is like most commonly used. Like whenever we are dealing with any large data set, we'll be maintaining pagination, and for every page we'll be loading only 10 to 15 records as per the limit that we have set. And not only that, later we can use infinite scroll. So as you scroll to the bottom of a web page, then the remaining 10 records will get loaded, and this is how it works, so on. And later we also have virtualized list. So virtualized list in the sense, so for the first time, our list will be loaded with 15 records, and as you scroll down, the remaining 15 records will be loaded. But again, when you go top, the remaining, like that already top, whatever the 15 records which are loaded, they will not load again. So they will be stored in some, like they will be stored in cache. And like this is how our Instagram also works. So when you load down the post, you will be able to see the loader sign. But when you scroll top again, the loader sign will not come, right? So how this is working, have you ever thought anytime? So yeah, this will be using a kind of virtualized list concept over there. And yeah, so this is how we can be dealing with large data sets. And yeah, and later, yes. So we have discussed many things, many optimization techniques and many features that we can use in our Vue.js, like how we can reduce our bundle and how we can reduce our rendering performance, how we can optimize our rendering performance optimization and many other things. But how you will be able to measure them? Like for example, yes, these are all the three tools that we have at present. So that is Lighthouse. Like when you inspect developer tools, we'll be able to see Lighthouse over there. That is the like bare minimum and basic thing. And later we also have Chrome dev tools, so we'll be able to see why our website is slow and which component is taking time to load over there. And later, bundle analyzer. So we have rollup bundle analyzer. So it is an npm package. When we have installed that, when we install that bundle analyzer, that roller bundle analyzer, we will be able to see completely visually which component is taking much size, what is the gzip size of each and every component, which file is taking much time to load, and each and everything. So let's just check one small demo. uh, so what is that is, so like for example, so this is a normal website which I have made, and in this website I have used yes, so this is the app.view. Okay, so in this app.view I normally have some router links, normal router links I have. So that is home page and settings page. I'll be showing both at a time. Yes. So these are the two home and settings router links that I have, and later this is the dashboard. And here in the router view, I am just showing all the pages that I have need to. And here I have two major two components, that is to do and model. Okay, so I am at present loading these two components using define async component. Okay, so let's just remove these using define async components, and let's just load immediately. Okay, and I'll load immediately. So for the first time, when I open this localhost 5173, I haven't opened this open model button and I haven't clicked on this load to do button. But still, these two components got loaded. So let's check also what is the chunk size that we have at present. Okay, so when I click on npm run build, so immediately we will be able to see each and every component is taking what is the chunk size. Okay, so here we can see the chunk size is of 98 kb, right? So let's just change it to okay. So as I've used that thing, you will be able to see also the app.view here, which is also occupying majorly the full space, I can say. So which is also marked as red. So red indicates that it is taking some much bundle chunk size, and we can also optimize it. And later you will be able to see the model.view and each and everything, how much size it is taking, what is the rendered size and gzip size. So rendered in the sense that is the raw size. Okay, the like file size is exactly of 61.25 kb, and gzip in the sense it got compressed and later it become 15.78 kb. So like whenever a browser takes something, it will take only gzips like files only, because our browser will not be able to take the whole raw file. It will first compress our file and later it will be processed. So yes, so this is one thing. Like I'll be closing this for now, and later you'll be able to also see that yes, that is 98 kb, right? So now I'll be using the define async component only later. Define async component, and now I'm just uncommenting these two lines again. So now let's see what is the chunk size it got reduced to. So when I click on npm run build again, you will be able to see much difference from the previous build to this build. So now you can see our chunk size is reduced to 4 kb, and also now the app.view is being completely reduced. Here there is no app.view here, and which is there, but still which is of very less compared to previous. And also there is no model.view loaded. Previously there is a component was there, model.view, which is loaded even before I used it. Okay, but now there is no model.view chunk in this bundle. Okay, so this is how you can reduce it, and later you will be also, you can also check from 98 kb it got reduced to 94. So like this is a basic application I have used just to demo. That is the reason you may not able to see much difference, but in major enterprise level applications you'll be able to see there is a lot of difference. And not only that, here as I also discussed about lazy loading in routes. So instead of loading the home component, settings component, and if we have other many files, like if you are dealing with any project level like complete a real-time project level code base, you'll be able to see many routes. So at that time, instead of loading all the components at present, like here import settings and imports about, import contact, each and every page directly here, we can load those components whenever we want. Okay, so it's like lazy loading component in the routes. So what this will do, this will load settings.view whenever I click on settings. At that time only the settings.view will get loaded. So this is actually the lazy loading concept in routes. And later I also have another thing, so that is when I go to the model, Yes, so these are all the different these are the different APIs, normal basic APIs I've used just to show how our synchronous component needs to be loaded in a different way. And I just wanted to show you the to-do. Yes. So here, like for example, I have a to-do. Okay. So like when I click on load to-do, a to-do application got loaded for me. So at this time only my to-do application will load when I click on to do. So now, for example, as I clicked on to do app, my to do application got loaded inside this. And now here, when I am adding this, view meetup. Okay. So when I click on add, these got added. So I haven't written this view meetup and each and everything in the same way. So I have maintained to do item as a different component, and there I'm rendering this. Okay. So this may be a very basic thing, but instead of completely writing the whole code, whole functionality of to do each and everything in a single file, we need to divide it into as much as simpler terms, like in a simple words, if I need to say, each and everything need to be very well organized. Like for example, add to do needs to be in a component, and what are all the to dos that we have needs to be in another component, and what are all the API calls that we are doing needs to be in a to do service. So this is how like code organized, I mean organized code looks like, and whoever the developer comes next will be able to understand very easily. So this is like another way. And at present also, here you can see the add to do, toggle to do, delete to do, each and everything I have written in the same file, but this needs to be moved in a API level. When I try to integrate with an API, so this definitely moves to a separate service. So this is how a code needs to be organized. So here, yes. And one more thing, if you have observed, this v memo is there, which I have made to filter to do's dot length. So what this will indicate here, so whenever this view meetup is there and how many times I'll try to render it, this part will not render, because whenever the filter to do's dot length, I mean like whenever you try to add any other new to do, whenever you try to add any other new to do's or delete any to do, at that time only these to do items will get triggered, and at that time only this will be getting rendered. So till that time it will be memorizes the length, and when the length changes, then only this will get triggered. Okay. So that is another thing. And I also wanted to show you the suspense fallback. Sorry, not suspense fallback, keep alive. So yes, so you can see now in the home page. So in the home page and in the settings page, yes. So at present, what does keep alive do? Yes, keep alive also does the same thing, which will keep our reactive things, reactive information in the same way, and it will not re-render again and again. Like for example, here I am using the like clicking on this button and made a counter value to 4, and I just went to the form and I written my name as Raven. Okay, but when I go to counter back again, my count will be as is as 4, and when I click on form, if the Raven is as is. So that means our component does not mount it again. Okay. So whenever the component mounts, our whole state will lost, and the new everything from fresh, it will get affected, right? So whenever you, there is any particular case where you wanted to store your state as is, you don't want to lose it. So at that time we need to use keep alive instead of like for example, if you haven't used this. Okay, so what happens at this time, like for example, I have used counter here and I clicked on form and I've written something, my name. Okay, so when I clicked on counter again, it sets to its original value. So that means my component again it mounted freshly. So this is another thing. And yeah, so these are all the different examples I have took and different concepts that I have took to explain what is actually the performance optimization techniques, each and every way where we can be able to check also how we can measure the performance optimization and everything. Yeah, so overall what are all the things that we can do here is measuring before optimizing, and later optimize bundle size first, and later avoid unnecessary reactivity, re-rendering and all. So lazy load whenever it is possible, and how clean the code is organized, that is how our application also looks, and also uh, like loads and renders and each and everything does proper way. And yeah, we need to continuously monitor our performance. It never should be lagged or delayed. Yes. So any questions you have, you can ask me if you have any questions.
I actually have one. You were talking about dynamic imports, right? And how we can reduce the chunk in
Yes.
its size. Is there any
Mhm.
trade-offs you can explain for our listeners? I mean, yes,
Sure,
we're
sure,
reducing
definitely.
the chunk size, the main one,
Mhm.
but we are doing that by splitting it to two other
Definitely,
chunks
I'll be
we are
explaining.
definitely we are dynamically importing into the component. So I just want you to clarify the trade-off of this approach.
Sure. So dynamic importing of a component is, so instead of importing these two components here directly, like for example, this form.view is there, counter.view is there. So for the first thing, actually I need not to import them directly, and I can import like this define async component. Okay. So using define async component only, I can import these two components, because I will not load these two components at a time. This is first thing. And second thing, here after importing using definition components, I am not using counter and form at a time here. So I am importing and I am using it dynamically. Like for example, when I am clicking on counter, so at the time when I click on this button, our current value is getting changed to counter. So that means counter component is getting loaded. The current component will assign counter component, or else when I'm clicking on like form, when I'm clicking on form, this form component will be getting loaded. So this is a kind of dynamic import of the components, like as per the like user input. At that time, whatever the component needs to load, that component will load. And here how I'm assigning here, so it's a normal component tag, and here to is property, I'm assigning the current component which is loaded. So for this also I have used computed instead of watch. Okay. So I haven't used current value to watch. I am using computed only, because we are doing some calculation here. And we are using dynamic import of components by using lazy loading components as well. So yeah, this is the best way, and this is the recommended way also whenever you are trying to deal with different tabs. Okay, so in many of the applications where we are dealing with many things, we'll be having tabs, right? Tab 1, tab 2, tab 3. So at the time we need not to load all at a time. Okay, so this is the best way to load the components dynamically, and also on demand loading. If
Okay,
you
great. Thank you.
I mean, like, did I clear? Yeah.
Yeah, it is clear. I mean, I wanna understand where is the more beneficial to use classic imports, because you know how Vue under the hood understands when do we actually need to use the chunk we just extracted by this dynamic import.
Okay, so like for example, I have to do. Okay, so this to do is separately loaded as a different chunk now. Okay, and there is another component. This is the home page component, which is loaded for the first time, and that is of this much size. Like for example, there is a component which will be loading immediately for the first time. So at that time, you need to import the component in a classic approach. Like for example, in app.view or in the home, like yeah, I'll be showing with this an example. So here, whenever I open localhost 5173 immediately, which components I'll be getting loaded here? Home page. So here, there is no use of importing component, header views and everything here dynamically instead of classic import. So whenever you import like this here, this is correct way, because whenever I open localhost 5173, automatically our home page will get loaded and home component will get comes into picture. And at that time we can use a classic approach of importing components. But whenever you are going to settings slash settings path, then only that settings.view component needs to load it, right? So at that time so we need to choose the lazy loading components of routes. And later you can also observe, as I have used like this, the settings.view chunk got separated from index chunk. Okay, and not only that, as I have used in app.view, like these are the two different components using async different async component. These two components are also separated from from the main chunk. So this is how you can optimize there also the chunk size.
Okay, so say in the simple words, the index chunk is the chunk that we are downloading every page we are visiting, right? But those
Exactly.
we separated settings, model, to do, they will be downloaded only when they actually need it on the pages they are
Exactly.
used in. Okay, yeah, thanks. That explained. Thank you.
Thank you so
Any
much.
other questions, guys?
Any other questions? Yes. So yeah, feel free to connect with me. Yes. Like viewers is a community where I completely focus on Vue and Meet ecosystem. So please do join me. And I am at presently working on making courses on Vue.js and taking each and every concept from a beginner to experience level. So you can also join me and helping me in doing those. And I'm also writing tech blogs on each and every concept of Vue.js. So yeah, please help me in doing that also. If anyone are interested, yeah, please do reach out to me. We will do something together. Okay, let's create something together. And thank you so much for giving me this opportunity.
Yeah, thanks, Shivan. That was really big chunk of information you effectively combined into this small amount of time. So thanks a lot. And
Thank
yeah,
you.
let's move on to our next speaker, Artur. Nice to meet you, Artur. So Artur is senior front-end developer at GitLab. Wow. Working on security policies and ongoing Vue 3 migration, and he's passionate about coding and running. Hello, Artur.
Yeah, hi everyone. Nice to be here. Very
Yeah,
nice
thanks for
evening to
joining.
talk about tech. First of all, thank you a lot for inviting me, and thank you to previous speaker for a very interesting topic. Yeah, I'm gonna share my screen.
Sure.
Just a second. Yeah. Let me know if you see my screen. Okay. Let's start. Yeah, a little bit about me. I was already introduced. I just want to say that I'm working at GitLab as senior front-end developer on security policy team. Well, so basically, if you had one of your MRs blocked by missing approval or failed scanner, probably I'm one of the guy who was responsible for the feature. Yeah, I'm working with you since 2015. So I have witnessed all three versions from 1 to 3. I was actively involved in the Vue 3 migration till December 25 at GitLab, and this journey already lasts for several years. Yeah, and I love long distance running, which actually helps me. This mentality helps me to work with Vue 3 migration at GitLab because, as I mentioned, it lasts for it's a marathon, basically. Yeah, what I would like to cover today. Well, this topic is very big and we have limited time. So it's very hard to dive into all technical details. So I'm going to try to tell you a story about different perspectives, how we plan this, how we organize the teams, how we dealt with breaking changes, how we were migrating key libraries, what blockers did we have, and I will try to um, tell you about some team coordination lessons we had, some progress tracking methods we used, and maybe some actionable takeaway that we had, but maybe it can be useful for your project. Some of them will be obvious. I hope some of them will be not so obvious. Yeah. What was the main challenge? First of all, one of the biggest challenges was the end of life of U2. It was December 2023, and it's a bit funny to say from 2026 that GitLab is still on version 2. Yeah, but we are working really hard to move it to newer version. um, GitLab code base scale. That was one of the biggest challenges. First of all, we have a mono repo. We don't have micro frontend, so it's impossible to like take a small part, migrate it to Vue 3, and do it without a micro frontends. If we migrate everything at once. So we had 4,000 plus components, 5,000 spec files, 68 developers who are all working only front end, all working in parallel. So there is a risk, always a risk to introduce more breaking changes. Growing technical debt, that's an obvious thing, that the more you work with legacy versions, the more legacy code you have, and the more you have to deal with in the future. Yeah, and certainly the business impact, the outdated code is more expensive to support. Some libraries can be outdated and supported. And of course, we can attract less talent, even though we have a very interesting technical product. Still, the young talents want to work with newer versions, and less people want to work with legacies. So, what was our migration strategy? So basically, we ended up breaking down everything in 4 key steps. At step 0, this was mostly planning. So we evaluated our code base, and we evaluated all our breaking changes that we have. Well, there is an official list of breaking changes that you can find on YouTube, and that's what we used for initially. And there is always a guide how to migrate from Vue 2 to Vue 3, also for previous versions of Vue Router and Vuex to newer versions. But for the code base like ours, there is always a risk of uncertainty. Even when there is a clear path and documentation, we found some obstacles on the way that were not documented. So also step 0 included adding some lint rules whenever possible. By lint rules, I mean, if we see some breaking change, we try to add a lint rule so new code won't have these breaking changes. Yeah, step 1, basically, that's when actual work started, and the result of step 1, we try to transfer, as you know, between Vue 3 and Vue 2, there is a, I would say, like helper version that allows you to run both versions in parallel. It's Vue compat mode. And that's what we wanted to achieve with step 1. We wanted to transfer our code base and related projects to Vue compat and identify blockers if we had any. With step 3, we wanted to make all our project and code base Vue friendly. It means that Vue compat works without any big problems, both in Vue 2 and Vue 3 versions. And as you know, Vue compat has flags that basically switch on or switch off the features that exist in Vue 3 but doesn't exist in Vue 2 anymore. So basically on this step, all our projects work with Vue compat 3, and we start to gradually disable flag by flag and testing that everything works. And certainly all blockers that were identified on previous step are also resolved on step 2. Well, and step 3 is the final lucky step. It's like when everything is working with Vue 3 and we can just gradually drop Vue compat support and Vue 2 support. That is how it was planned time-wise. Ideally, we wanted to be able to make it till end of life with Vue 2. But as I said, this project was like a rabbit hole. The more you migrate, the more problems you have. So where are we right now? It's actual timeline. We're still on step 2, and we're adapting we're adapting our giant code base to work with Vue compat and Vue 3 friendly mode. But good news is we're almost there. I think in another 6 months we will be able to use Vue 3 in well, this is a very, very careful prognosis. I hope it's going to be like this in 6 months. So yeah, how we try to organize the team working on Vue 3 migration, because I mentioned before we have a lot of developers, and on the initial step with planning, we try to involve the most talented and knowledgeable developers, basically architect level, principals engineers, and staff engineers. They were mostly involved in planning and creating a way to go, breaking down all features to smaller tasks. Well, this approach has some advantages that you have like the most knowledgeable people to your disposal, but the capacity of people like this is limited because they still need to work on key features of GitLab that our users want. That's why you can involve them only in planning, and this is a limited capacity. And if you care if you care about company finances, this is going to be most expensive planning, because the hour of this developer is the most expensive of your company. Next approach that we took, this turned out to be beneficial at the beginning, but had some disadvantages on the way. Basically, we have a lot of feature teams, and we made a call to all our teams to participate in Vue 3 migration. Basically, it was in volunteer base. Anyone who had capacity from a big front-end team could contribute in Vue 3 migration. And at the first, with a very high motivation, and we increased our capacity and were able to move in a fastest pace. But this approach has some disadvantages. The motivation fades with time, and also developers are busy with their main duties with the features, and we ended up some tasks were taken in progress and abandoned in the middle. And when new developers come and has to start all over, it takes more and more time. So, and finally, the current stage, and which we find the ideal work setup, basically, we broke down every problem areas into features or topics, and we created epics, and we have a smaller dedicated working groups they consist from 1 to 3 developers. It's very important that one group works only with one feature and have a lifespan. Basically, if you have a work group without any time limit, it's gonna be fixing this forever. But if you have a lifespan, at least you can plan and somehow coordinate your group. I don't know, the simplest example I can give you is like methods like view set and view delete were actively used in Vue 2, but they were completely removed in Vue 3. And we had a working group specifically dedicated for that feature that basically refactored all the places where view delete and view set were used, and they refactored to the code that is both working in Vue 2 and Vue 3. Yeah, and one of the key advantages compared to the previous approach, when you have a volunteer-based approach, it means there is no directly responsible individual. And unfortunately, when everyone is responsible, no one is responsible. And with a working group, you have a directly responsible group who is actively responsible for the feature, so the progress is more or less visible. Yeah, how we dealt with breaking changes. Well, our most efficient approach, it can be probably obvious, but we tried and error couple of approaches, but I still want to say it out loud. Yeah, as I mentioned before, we took one breaking change. We identified all components that have this breaking change. Like we can refer to our example with view set and view delete. Basically, we created a quarantine list, or you can say quarantine list or exception list. I can explain why you need this. You can imagine that if you have a code base with full of view sets and view deletes, and you have a team working refactoring these methods, there are still 50 developers that are working on the code base in parallel and sometimes not aware that it's not longer allowed to use view set or view delete. Well, you can announce it, but the chance that there will be developer who still like miss this information and gonna introduce the code with new breaking change. So you will need somehow to block users from creating more and more breaking changes. One of the steps you can take is creating a lint rule. But if you introduced a lint rule with a code base full of view sets and view deletes, well, you will break your code base. So the linter will always fail. The pipeline will always block your merge request. But basically, you identify all components that have view sets and view deletes, and you make this an exception list, or we call it a quarantine list for your lint rule or your pipeline. So, and this will allow you for your code base to run, but it prevents other developers to introduce more and more breaking changes. Yeah, you create an epic and you break it down to many issues. Well, the ideal approach is have like one issue per component, because granularity is very advantageous when you plan your work, especially if migration topic is the side project from your key work. You can always slip in 1-2 issues into your planning in sprint, and you can migrate you can solve 1 of 2 migration problems during sprint. Yeah, this one is what I mentioned before. We had a pipeline with we created extra job that we're running in Vue 3 mode, and basically it failed in 2 cases. It was failing in 2 cases. First case was when the user tries to introduce a code with break and change. For example, a developer that was one where creates a merge request with view set. This pipeline would fail, saying it looks like you're introducing the component that is not in quarantine list and you're creating a new change. This is not allowed, so you cannot merge this. This is one case when the pipeline was failing. The other case, if, for example, you worked through the list, you took one item from the quarantine list and you refactored it, you fixed the problem, and now you want to merge it, but you forgot to remove it from a quarantine list. The pipeline should fail as well, saying, looks like you fixed the problem. Don't forget to clean up your quarantine list. Yeah, basically you work through the quarantine list, and finally you enable your lint rule in full power to prevent new code from happening, and now every component is affected by a lint rule. You cannot modify your old components, you can introduce new components. This approach works well in parallel. That's why it's efficient to break it down by the teams. So many teams can work on one feature at a time in the parallel. Some disadvantages of this approach. Well, if you were able to make it an ESLint rule, this can be efficient. But for example, in GitLab case, I'm going to show you an example with a pipeline. We could not, just a sec, I'll open it right. Yeah, as you can see, we had a lot of jobs we run in just tests, and you cannot just identify all potential problems. You can identify problems in components with lint rules, but tests are different. So you have to run the similar set of pipelines in Vue 3 mode, and that's how we do it for tests. And for projects like GitLab, if you have a really big code base, cost of pipelines can be biting. Yeah, a pipeline time that you need. So this is a disadvantage of this approach. If you can afford it and it's necessity, please go for it. But if you can solve your problem with ESLint rule, go for ESLint rule. Yeah, I'm gonna briefly mention how we were migrating key libraries. GitLab codebase use all standard libraries of Vue ecosystem, like Vue Apollo, Vue Router, Vuex, Vue test utils, and most of them were migrated without big problems, except for GitLab UI, but I will tell about this later. We use a very straightforward approach. I'm not gonna spend a lot of time on this on our presentation. Our code is open source, so you can always check Vue3 compile folder in our code base. We created transformers. Basically, this is a transformer that patches features that we have in Vue 3, but no longer have in Vue 2, or like don't have in Vue 2 at all. So this transformer patches the missing functionality, and when we start it's our webpack config, it's very big, and when we start our code in Vue 3 mode, basically all aliases are pointing towards these transformers, and in that case we can run basically all these Vue 3 libraries together with still Vue 2 version, creating this using these patches. Well, you can always all this open source, you can dive deeper if you want, but this is the concept that we're using. Yeah, this is how it looks more visually. We support both Vite and Webpack. We're trying to transition fully to Vite, and we're 95% there, but that's why we still support Webpack, because we still need to work on some changes with Vite. So our production code runs now in Vue 2, and this is very straightforward approach. We compile the version in Vue 2, but with Vue 3, as I showed you, the output use these transformers that allows Vue run all these new libraries in Vue 3 newer versions, but still work with Vue 2 mode. Yeah, and now I was not the part of the hybrid mode project. Hybrid mode project is a very interesting, exciting, complicated thing. Complicated for me because I didn't have time to dive deeper. This project started in February. Basically, if you are interested, there is an open merge request. It's also open source. You can read more about it, but it allows Vue 3 and Vue 2 runs in parallel at the same time. It's like sort of custom compiler at GitLab that basically it marks the chain of components that uses Vue 3 libraries and unifies it for Vue 2 components. It's like I'm sorry, I would like to tell you more about this, but I'm not in so deeply in details about this. But this merge request is open. You can find it by just Googling it. So yeah. And here the main blockers that we have on the way. When I was talking about steps, I mentioned that we have to identify the blockers. And while we were working and planning, we identified two big major blockers. First blocker, it was our own component library. Our component library used Bootstrap Vue as third-party dependency. Well, historically, we used Bootstrap Vue just to start our component library, and we used Bootstrap Vue for complicated components like tables and forms. But a long-term plan was to gradually develop our component library and gradually drop Bootstrap Vue and create our own table components. but the last step never took place. So we ended up with a component library with the Bootstrap Vue dependency. And Bootstrap Vue project has no immediate plans to support Vue 3. So basically our code base is, I think most used components in our code base are our component library component. And this was the major blocker for us. Uh, one of our developers, it's a very talented and knowledgeable person from our team, uh, who contributed to Vue project a lot. He tried to contribute to GitHub project of Bootstrap Vue to make it Vue 3 compatible, but the amount of work was unbearable for one person. So we had to end up with another approach. We forked completely the Bootstrap Vue, and now we're refactoring the problematic components. And well, in that case, we can basically the biggest challenge we have with the table, because table is very big, and now we're working on, well, we're no longer dependent on releases of Bootstrap Vue. We have our internal fork, and we are gradually refactoring the table component to support Vue 3. We're almost there. After we finish it, we can just drop the whole dependency and the whole fork projects, and we're gonna use only our pure component library. Well, what actionable takeaways from this? Some of them are very obvious. Well, maybe advice number one, it only reliable to big companies that have a lot of projects and use own design systems. If you can afford to develop your own component libraries, it's basically a nice approach for giant code bases. And like most often it happens, big companies, big tech companies, they have all own component libraries. They are not dependent on third-party libraries. If you depend on third-party libraries, try not to use third-party libraries like directly in your code base. Still, you can create a wrapper around it. You can unify APIs, and you can populate your code base with your own wrappers. Like we don't use B button from Bootstrap V. We have like GL button, it's our own component library. Even though GL button uses it used to have Bootstrap Vue button inside, all the APIs were unified how it was used. So all the events that were coming out of a GL button, our GitLab button, they were known. This API wouldn't change because we control it. So basically, if you have the problem with the third-party library, with this unified approach with the wrappers, you can just switch the library, and this would require less effort to adjust one wrapper, and then it will magically work for all your code base, rather than you will have to identify all hundreds of places where you use the library directly. Yeah, and refactor it. Yeah, do not rely on single person initiatives. Yeah, it's an obvious one, probably. Establish a dedicated migration team if you work on it, because it brings us back the approach I told you, where when everyone is responsible, nobody is responsible. Yeah, try to adapt gradual decoupling strategy, basically work component by component. We have almost finished the migration of the library. We're almost there. We are now in the stage where we're doing final testing with the code base, and hopefully very soon we're going to completely drop Bootstrap Vue. Yeah, if you think that migrating of component library is tough, is just wait. Migration of front-end specs was another challenge. Every component, and I mentioned that we have more than 5,000, has a unit test. And basically, when we started our test in Vue 3 mode, we had 800 failing test files and over 5,000 failing test cases out of 66,000 that we have. Yeah, and this was much harder to identify, because there is no guide like you migrate your component, you go to official documentation, Vue 3, Vue 2 migration guide, you see the problems you identify. But the test, it was failing for unpredictable reasons. And often the error that you see in the stack has absolutely no relation to the actual error. So why tests were failing? Vue 2 was more forgiving compared to Vue 3 in type checking. By type checking, I don't mean TypeScript, but for example, in Vue 2, if your template is referencing a data property that doesn't exist in data, the test will still pass. I mean, if you not actively test this part of the component, the test will be green. But Vue 3 will not forgive the missing property, and it will fail your test that you forgot to create a default in data property in your Vue component. That was one of the reasons that was very hard to track. Full mount, yeah. Cases when we had a component with a big tree. For example, you have a parent with a lot of nested children, and some of the tests were written with full mount. So basically, you mount in full not only parent, but all the nested children, and you can have like 5, 6 level of nesting. Vue 2 will tend to be more forgiving with that, but Vue 3, if you, for example, if on the lowest level of your tree, you have a child component that uses a Apollo query, and you forgot to configure your test to mock all the Apollo queries in your parent in the test, this will pass in Vue 2, but will fail in Vue 3. So what the main advice? Well, of course, if you have a unit test and you're using full mount for the big tree, most likely the test is not organized properly. Basically, when you create a unit test for component, all you need to test that you accept correct properties, you render correct HTML based on the properties, and you emit correct events when some buttons are clicked or inputs are filled. Basically, you test your component, its functionality, and the interaction with the closest either parent or child. Usually, you don't need to test the whole stack from the deepest child to the highest parent. If you need to do that, this is more likely not a unit test. This is integration test, and it should be probably written only once. And you can have a special folder for integration tests, because yeah, the key takeaway: prefer shallow mounts and stubbing before full mount. It can work in one version, but it can shoot you in the foot in the next version. Snapshot testing was a big problem. I'm personally not a big fan of it, but it's subjective. Even though HTML outputs were same, the serialization had a problem with spacing, and it required us to write like a mapper that serialized spaces correctly. So a lot of tests were failing in Vue 3 because of the just different number of white spaces in the output render. Yeah, white box testing. By white box testing, I mean some tests were written that instead of triggering the button, internal methods were triggered. This is not the best approach. We always need to rely on a black box test when we throw in the properties and emit out events by clicking buttons. We don't need to involve clicking method or checking computers. Basically, we don't need to never need to test internals. So some tests were using this approach. I will show you one of the examples later. They used to test internals, and when you rely on internals, Vue team can change the internals, and when you run your application in Vue 3 mode, the method you are trying to trigger in Vue 2 doesn't longer exist in Vue 3. Yeah, and some other problems that we had, it's certainly the migration of Vue test utils. They had some breaking changes, but it was more or less straightforward. Subtle component bugs that were really hard to identify. I can show you an example. This was failing the test in Vue 3. For some reason, um, two objects were compared by 3 equal sign. Yeah, and this was magically passing in Vue 2, but was failing in Vue 3. So, and it was really hard to debug. Linters won't help. That's what I meant with testing. You need to have two sets of pipelines because linters can totally skip this. But it's just like one small example. Certainly for B, it requires more context, but yeah. As I mentioned before, it was very hard to identify the problems. For example, the problem I showed you that was failing the test had the error message like this. So basically, it has nothing to do with the fix I applied. And 90% of failing tests had messages like this. Yeah, that's what is very hard to debug. And it took us over a year, 1.5 years to fix all the tests. Yeah, AI assistants nowadays with the current models, probably they would help us a lot. But a year ago, we tried to integrate AI to help us identify the problem. But in most cases, it just created right inside the test. It created a mock of the component that passes the test and tested this mock and not the actual component. That was, yeah, the tests were green, but it didn't fix the actual test. It didn't fix the actual problem. Solution was pretty similar. As I mentioned before, we identified all failing tests, created a quarantine list. In this case, we had to create a pipeline that runs all tests in Vue 3 mode. And of course, these pipelines were ignoring our quarantine lists because otherwise no one could possibly merge new code. But it prevented us to introduce more failing tests. That's how we were able to work through the list gradually. And actually, I was the member of this migration group that was focusing on tests. And we had a small party when we finished all 800 failing tests, and it took us 1.5 years, I think. Yeah, but this list is finally empty. Yeah, pros of this approach, as I mentioned before, dedicated migration team that is very focused on one, and it's not one person. That's why it's more reliable. Developers that are not directly involved into migration cannot introduce more breaking changes and tests. Yeah, but simultaneously, it was a bit a con of this approach that our migration team consists of 4 or 5 people. And after a year, we were very skilled with fixing failing tests, but the developers who were not involved in migration, they could add some feature. And with the linter, it's very obvious. You see the linter, you fix it. But with the test, for example, you create a new component and you created a test as you used to create the test. It's green in Vue 2, and you create a merge request, and it's failing in Vue 3 pipeline. And without this knowledge that our migration team had, the developer had to spend some time to figure out, or of course, it was our team was known for most of the developers came to us, but still, as a disadvantage, it requires more time to merge the merge request. Yeah, and as I mentioned before, the cost of pipelines can be quite high for big code bases. Yeah, and as I just another, I just wanted to reiterate. Sometimes some tests where we were able to fix in bugs where errors were similar. However, most of the cases had to be fixed one by one. Dedicated groups were formed, yeah, and the effort was really focused. Yeah, the current progress, as I mentioned, we were very happy that we have now 0 failing tests. Everything is passing. Yeah, some actionable takeaways from this approach: prefer shallow mounts to full mounts, because if you need a, well, you rarely need a full mount for unit tests. I think 90% of the time, shallow mount with correct stubbing will do. Yeah, use the stubbing strategies. What I meant relying on internals, I made a test like this when a user wanted to mock the init event of this API. One of our developers tried to go deep into the internals, take the first array, and mock the init. But surprise, surprise, this API didn't exist in Vue 3 anymore, so the test was failing. Yeah, sometimes I met approaches like this. This was a very popular approach to test validators in props, because Vue used to throw a console error in Vue 2 when the validator of your prop is failing. So some developers used to spy on just a console error to verify that the prop was invalid and the validator worked. But in Vue 3, instead of using error, the team decided to use warn. So all tests that used this approach failed. Yeah, and to unify tick events, because it turned out that when Vue 2 needed only one tick for between re-renders for some cases, in Vue 3, it required 2 or 3 ticks before the re-render happens. And if your test doesn't account for that, it's probably going to fail in Vue 3. So we used a very universal helper that we wrote ourselves, basically waited till all promises are resolved and all ticks are happening. And after that, it checks the test. And this is unified approach, and most tests, like the post tests in Vue 2 and Vue 3 will be green. Yeah, and I just wanted to emphasize the migration strategy at the end of our call. For it worked for us for most of the breaking changes, key libraries, and tests. Identify the problem, form a dedicated group, identify all components with breaking changes, organize work by epic, define working group lifespan, manage current in code, fix current items iteratively, enforce new lint rules, disband the working group, and move forward. Well, as I mentioned, we're still on the way, but at least this year, this way is very bright, and I hope in next 6 months, GitLab will be able to completely switch to Vue 3. This was our short story about Vue 3, about 4 years of Vue 3 migration, already 5th year. Yeah, if you have any questions, please let me know. I will try to answer as many as I can, but just a disclaimer, the topic is very big and I may have gaps in some areas. So yeah, let me stop sharing the screen. For some reason I can't. Yeah.
Well, that is really huge. That is really huge, and that's, you know, your experience is just immeasurable.
Thank you. Yeah, it's all open source. So if you have an interest to dig deeper, um, please, you're always welcome. And anyone can contribute. We had a lot of community contribution issues labeled. If you want to jump in and try to solve one or two epics, you're always welcome.
Yeah, that's really impressive experience, and thanks for sharing. Thanks for sharing it with us. I can just imagine the amount of stress on all of this period, considering the size of the code base. And also, that's interesting that you were talking about UI library that was a clutter at some point, right? So you decided to build your own based on the fork of Vue Bootstrap. So
yeah, just to maybe if I said something not correctly, when we were building our own library using this third-party library, we were Bootstrap Vue, like we used it for a kickstart, but it was before my time in GitLab.
yeah, for me, it's just interesting that how we went from we're building simple stuff using only HTML and CSS as a components. Then we went to like, let's make UI libraries that can handle everything you just can imagine. And then we are getting back to simple stuff like styleless components that just providing some functional things. That's what also John is mentioning about the Vuetify 0 here.
Yeah.
So yeah, that's quite interesting tendency. Yeah.
Yeah, that's true. That's what was one of my points. So basically, if you can afford something that you can, if your project is really big and you can afford something that you can control without third-party big dependencies. Of course, we all use npm packages and we're gonna continue to use them, but big dependencies like the whole libraries is can backfire sometimes.
Yeah. Okay. Let's take a quick look at the chat. Do we have any questions there? I think we have one from Yevgeny. He's asking, why didn't you decide to do more gradual approach with features? So for example, micro frontend split.
Well, considering we historically had a monorepo, and with the amount of code we have, it was a debate between like creating a new approach with micro frontends or and trying to migrate them one by one and still having a monorepo. So I actually don't remember why, but the monorepo approach won because our architects here a clear vision how to migrate to Vue 3, and they basically pursued the stakeholders to continue with this approach. But to be honest, our newest features, the most like GitLab Duo, it was architected like a front-end island outside of main code base. It's already using Vue 3, and I see that this approach is working, but considering it is doable with new features, but considering the amount of existing features that we have, I think maybe with AI it will be quicker, but if we do not take AI into consideration, switching to front-end, micro front-end approach will take maybe another year or two, or even more. Yeah. So basically, it was all about timeline and costs.
Oh yeah.
With the existing code base. Yeah.
Yeah. Thank you. Another question we have in the chat: what advice would you give to teams that migrating projects where decoupling was not done in advance?
If you mean like repositories like ours, when it's by decoupling, if you mean using like micro frontends approach or more isolated approach, if you have like a monorepo like ours. So basically, you can utilize our approach with transformers. If it's not a giant code base, it can be beneficial. Uh, with transformers, you can migrate to Vue 3 without refactoring, because you use transformers with existing code base, and it runs in Vue 3. And you can already deliver features in Vue 3, and you can refactor old Vue 2 code very gradually. But if you don't use transformers, and like the straightforward approach with monorepo would be like make the whole code base work with Vue 3 first, and it requires you to work through all the features before you can switch to Vue 3. It would take much more time. It's much easier to use transformers, switch to Vue 3, and then refactor all code, because you already can work with Vue 3 rather than first refactor and then switch. Yeah, I hope this answered the question.
Yeah, that makes complete sense. Yeah. Okay. So I hope this answers the question too. I don't see any more in the chat, and I think we will finish at this step. So thanks, Arthur. That was really
Thank
huge.
you very much.
Really huge experience, and thanks for joining our meetups and sharing your experience here. Thanks a lot.
Yeah, thank you for inviting me. You have a great community.
Yeah, I hope so. So I'd like to say thank you everyone for joining our meetups. That was our 18th one. Let's meet together again in our 19 in the next month, guys. Thanks for joining, and bye-bye. Have a nice day.